Alright, well, this will be the first installment from One Crafty Dude, introducing my company Hydrotek.net. That's HYDRA-TEK.net. What I'm introducing today is the silver bullet. This is the silver bullet. The silver bullet consists of four tubes and one electrode. The electrode is machined out of 316L stainless steel. Now these cells currently go for $225 in the non-electro polished form. This will not be carried in the near future because we're going to an electro polished version which produces a tube which is passivated, and that means that it's impervious to the destructive forces placed upon it in the electrolysis process which we use to make hydrogen. Now, my cell is a series cell, but there's other people who call it a dry cell. A dry cell, the criteria for a dry cell supposedly is that it is not submerged in water. This type of cell, which many people have built, is meant to be submerged in water. And when it is submerged in water, it becomes inefficient because each plate is getting 12 volts. What we've done different is we've dropped the voltage down 4 times in our cell. By doing this, we're getting 3 volts at each reactive surface. 3 volts at each reactive surface lowers the waste heat generated by waste amperage draw. In order to make hydrogen, you need 1.5 volts per conductive surface. Any more than 1.5 volts per conductive surface creates waste heat in the form of excess amperage, or vice versa. So what we found is a compromise between maximum efficiency and cost effectiveness, as well as the limitations on how you can mount these systems in a car. Now, as you can see, my system utilizes straps. The straps come with the cell when you buy it. These outer straps can be adjusted to any length. They have holes in the strap which you put screws through into a body part that's grounded. That utilizes the outer surface of the cell as the ground, and the electrode is connected to the positive, which comes from your relay, so that when you turn on the power to the relay, the power is transferred through the relay into the electrode, producing hydrogen. And you'll see the hydrogen start to be produced in the tube. This is a full bath type cell. It's always full of water. The location of the bubbler reservoir is very important for this to work. For this process to work, the bubbler / reservoir must be located above the exit tube on the cell. This creates a gravity feed from the reservoir to the bottom of the cell, where there's a recirculation loop that flows up, creating an ion pump through the cell while you're producing hydrogen and oxygen, and forcing water with the hydrogen and oxygen back to the reservoir. This convection loop helps in cooling, because we do have waste amps, not a lot of waste amps, but we do have heat being generated from the waste. Now, these cells do not overheat. Most cells do overheat, but this cell does not overheat. It operates at a temperature of around 80 to 100 degrees. Now, the higher the amp draw, the higher the heat will be. But what we found is A common misconception out there right now is that you need more hydrogen to get more benefits. And what we've found is that's not true. What you need is a steady supply of hydrogen, but it needs to be at a level that will not produce detonation in an engine. Detonation happens when the concentration level of hydrogen is too great for the timing. Normally in an engine, this being the piston, this the top of the head, when the piston's on the upstroke, the spark plug will fire before top dead center. That would be here. So normally the spark plug fires here, the piston's on the way up. As it reaches top dead center and starts to come down, the fuel combusts because of the low quality of the fuel, and it's burned as the piston goes down. That's a very inefficient fuel. Now when you add hydrogen to the equation, eventually you run into what's called, or at least what I'm calling, the threshold effect. And the threshold effect occurs when the concentration of hydrogen is too great for that timing of the engine to ignite the hydrogen after top dead center. So as the piston is coming up, the spark plug fires, and the hydrogen, which burns a lot faster than gasoline, ignites before top dead center, causing the piston to slow down as it reaches top dead center, and then being forced past top dead center by the fuel burning. So what we found is our cell will produce 1 liter per minute at around 10 amps. This is more than enough hydrogen for a V8 powered engine, V8 engine in most cars. What we found in the 4 to 5 liter engine size is that between 1/2 and 1 liter of gas is required before you meet the detonation problem or the threshold effect. Now the only way to combat the threshold effect and utilize more hydrogen than that is to retard the timing past top dead center before the fire happens. But for now, maximizing the amount of hydrogen in the engine, the combustion rate is done between 1/2 and 1 liter per minute, and that's 10 amps or less draw on the silver bullet. The silver bullet will stay cool, like I mentioned, and it does not produce mud. The reservoir is where it's topped off. You don't take the cell apart unless you want to see what's inside, and what is inside are the multiple tubes, like I showed you, which break the voltage down. Now these tubes have been electropolished, and you can tell by the color of the tube that it looks more chrome than it did stainless. Now this bullet has not been electropolished, and it does not produce mud either, but it will have a slightly higher amp draw and require just a little bit more sodium hydroxide to attain the same levels that the electropolished cell will attain. Also, the qualities of the electropolishing allow for a longer lifespan without the possibility of failure. Now you'll also notice that there are no electrical connections inside this cell, and it's always in a full bath solution. These are two big improvements over just about every cell design out there right now on the market. If you can find one to buy that you don't have to make yourself, most times it'll have some type of electrical connection going through a container. And what we've found is that this is a weak spot in all designs. So we have engineered electrical connections out of the cell. We've developed a cell that's very simple, very easy to reproduce and manufacture, and it comes with a 2-year warranty, which I don't believe anyone else that's